Hello dear viewers, welcome to my channel Science to Technology. In today's show, Camera Tuesday, we're gonna talk about why high-speed videos is so goddamn expensive. So let's dive deep into it. So exactly what is the problem? Well, high-speed shots like a quality shot, and let that be very clear, technically your mobile phone can even do 960 frame per second, but you know the output, it's hulululu, it's garbage, it's useless. So if you want a quality high-speed shot, like, and I'm talking only 1000 frame per second, I'm not talking like 70,000 frame per second, I'm just 1000. It's expensive, it's bonkersly expensive. So why is that? Well, here's the deal. High-speed camera was not made for glory shots. It was not made for, like, movies and all that. It was made for mostly rocket industry and nuclear boom boom devices, as in like how the heck things happen. So you need high speed camera. Thankfully nuclear did solve one of the issue of high speed camera. You did not have to worry about exposure. It was like, I got you, fam. So that's how it started. So you can understand that if people are building something very niche within a niche item, the price was like stupid, and it was scientific, so there was not enough, like, demand or competition or anything like that. It was just like, we need this, anybody like can make it, okay, somebody can make it, take money, go, done. So it was very expensive, and worst case scenario of that was that it created what we call feedback loop, meaning it was very expensive, that led to low sales, meaning the company that is making it, they have to increase the price of per unit so they can actually recover the cost. That created a much slower development cycle, as in the ecosystem of the high speed camera did not progress as quickly as even in old days film camera, because film cameras was sold to every movie director and all that. So development on those technologies were bonkersly fast compared to basically high speed camera. Is like, they were only selling few of them, and most of them were being rented out. So now, Apollo era did consume high-speed camera like there is no tomorrow. And during the Cold War era, especially with Minuteman missiles and boom devices, they were like buying high-speed camera like there is no tomorrow. But not if for movies or commercial and things of that nature. Some people did try it, but it was expensive. So at this point in time, Phantoms come into the picture. Now, Phantom is a high-speed camera that is very good quality system, but here's the deal. They are so goddamn expensive. You go into Phantom, you go into product, you select a camera, it does not even show the price. It is like get quote. And be mindful, the mid-range of those puppies are $100,000 above. So yeah, although I hate this idea of get quote, because again, the price will not change. Tax might change, price will not change. So like, just show the goddamn price. So this is the whole idea. Like, if it's that expensive, so like, it was a big deal for movie 300 to have that many high speed shot. And be mindful, that was film high speed. So it was difficult, let us put it that way. So there is a genuine problem. Like, you want like a whole movie shot in that. Again, technically your mobile phone can do even higher speed than this. It's just that the quality of that would be poo-poo. So let's dive deep into the core of it. Sensor, as in, how did we start to do it? Now, again, if you know anything about film camera, you know for a fact that film camera does not go swing smooth. It does not go like, it has a krrr sound to it. It's simply because there is a Geneva gear set system that takes a frame, plonks it down, then exposes it, and then removes it. It's always like, it's not in a smooth motion. Even though reel looks like it's moving, it's like, that's why that sprocket holes are there. It's like, moving in complete steps, and it's stopping all the time. But here's the, you cannot stop if you want to do a high speed. If you want to achieve, let's say, instead of 24 frame per second, 1000 frame per second, that act of stopping will destroy the either equipment or the film itself. So how did we solve it? Well, somebody figured out, hey, what if you do not stop it? What if you just let it run like on a high speed roll, and you just like go, okay, they did it. Okay, then how do heck you project exposure into it? Now, for shutter, we solved out, because again, the still image shutter is like this. That is too cumbersome. It's like going back and forth. It's not good enough for video. So they created disc. That's why you always get in your video camera, it says like, 90 degree, 180 degree. That's literally that disc. That disc, if that disc has a like 90 degree cutout, it's 90 degree shutter. That's why I said like it's 1/4 of the FPS that you are running on. And it's like, okay, 180 simply means like axis is here, half of them would be there. It could be even smaller also. So that's how they started putting system. Somebody came up with the idea, hey, throw that puppy away, put prism there, and spin the prism at the same sync speed as the basically the barrel. And benefit of that is the prism is acting as a like a physical light shutter, where it's opening and closing, opening and closing, opening and closing. So that's how it does, like open, exposure, closing, and it's in sync. So it's exposing and then pulling it away, exposing and pulling it away, exposing and pulling it away. This allowed them to achieve, like, in 1960s, upwards of 1000 frame per second. And it was actually, it made like whole the Apollo era high speed cameras like, bro, it's done. And again, that's how it started. I'm pretty sure they went up to ludicrous speed, although the barrel was limited, as in like how much film you can have. So it was barely a few seconds, or maybe I think later they reached a point where it's like, okay, we can give you 1 minute of high speed. So that's how it started. But again, it consumed film like, it was very, very powerful, because again, somebody figured out you do not want to stop. You have to do it in continuous motion. Think in this way, instead of having a puppet valve, it has a rotary valve. So that's how we got started into high-speed camera, and this made like high speed a thing. And for engineering, car crash investigation, it became sure to take money. Then we come into digital era. Now here's the deal. Digital sensors improved surprisingly early on, especially with CCD, although the hardware behind the sensor was painfully outdated, as in like it was not able to keep up. The CCD, we good, especially if you had a bright enough light. So CCD was like, bro, I got this. And the data acquisition part is like, yeah, we can't keep up. So early digital cameras, somebody figured out, it's like the only way to get super high frame speed. Like if you really want to capture like late 70s and 80s, like, nuclear boom devices, how the heck you gonna capture that? It's like, okay, put boatload of CCDs, and I do not mean one or two. Boatload as in like 100 or 200 of them. So you literally have a camera card that is like the sensor, a capture buffer, and that's how you. And then you have a mirror that is projecting in all of them, and like tuk 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 tuk, and each of them is only running at like, let's just say 1000 frame per second, but you offset them little by little. And benefit of that is, and because mirror is doing the projection part, it can be done so quickly that you can have million frame per second doable. Now again, they did not reach million frame per second because CCD was not that good, but 10,000 frame per second, 20,000 frame per second, that was like, bro, take it and go. And again, this is 70s. But it did have an issue that, because again, there were only so many cameras, and even if the mirror can come back and actually expose again, the back end was like, not, bro, we good, that's all we're gonna capture. So the FPS was very high, as in like 10,000, 50,000 FPS. But how many frames? It was just how many cameras you had. So it could be as low as like 300 frames, and not like, okay, 1 second, or no, 300 frames, go YOLO. That's all you're gonna get. So that's how we really jumped into high-speed digital photography. And CCD was a very king. Even though CMOS started to capture the market in 90s in basically photography world and digital videography world, it did not replace high-speed camera simply because CCD was day one global shutter. It literally captured the whole thing. CMOS was like, rolling shutter. So that was no way to replace that. So it took a lot of time for high-speed camera manufacturer, digital camera manufacturer, to jump from CCD to CMOS, because they had to wait for global shutter development. It took time. Let's just put it that way. It took time. Can you make a basically modern CMOS system with rolling shutter? Yes, but why? Like, it's dumb. Why? So that's another thing. And one of the biggest hurdle that why can't we just have like stupid high FPS is simply because while the analog element of your sensor, as in like crystal that is absorbing photons, converting into voltage signal, that can work at any speed. That's like, again, it does have light speed as an upper limit, but it's like, bro, I'm good. But then why the heck, whenever you are buying a sensor or looking into sensor data sheet, it always says what is the upper speed? Because CMOS have the analog to digital converter on the back end of the sensor. So whenever you see the backside illuminated, what the hell that means? What are these wirings? You would think, oh, there will be only X and Y, Z wiring. Why the hell there are so much? Yeah, that's the analog to digital converter, literally on the pixel sensor itself. So you have the active sensor array, and then the CMOS is literally acting as a compute element on the back end of it. So analog to digital converter and sensor nowadays is just one unit. Now it keeps the cost low, but does create a scenario. If you made a very awesome sensor block, it is tied to a dedicated analog to digital converter, meaning you cannot just like, hey, I like that sensor's quality. What if you just throw away that low cost analog to digital converter, put some super duper high speed analog to digital converter, and you make it as big as it needs to be? You can't do that. CCD you can. Like if you go to NASA and like, okay, NASA is building a system for CCD, it's like how they are building it. Most of the CCDs actually give analog data output, and that analog they tune a hardware specific analog to digital converter, A, that it can work in space, B, it works exactly as they want it to, at speed they want it to. So that's decoupling that there used to be, that you sandwich it together, it created an issue. It's like you have to buy the sensor from day one that does the maximum limit, as in like sensor itself is the limiting factor. Even though sensor, the analog part can read super high speed, like let's say 10,000 frames per second, it's doable. It's like silicon does not care, it has enough response curve where it can act to it. It's just that the analog to digital converter on the back end is like I can't read that fast. So, and that's why whenever your mobile phone does high speed footage, it looks poo poo, because the analog to digital converter is like, yeah, I can't digitize this quickly, so skip lines. Okay, I really can't digitize this quickly. Okay, skip bit. So instead of trying to take 12-bit, compressing it to 8-bit, then giving you a quality image, it's like just read 8-bit, skip gaps. So color quality looks horrendously bad. And again, even in skipping lines, it also starts to skip pixels itself. It's like, yeah, I can't read this fast. So that's why even though on principle your smartphone has the same lens, same sensor, the moment you try to do 1000 FPS, the output is poo-poo. That's the reason. The analog to digital converter that is on the back end of the sensor, that's the limiting unit. So even if you are like, hey, I want to make a high-speed camera, you can't really do that with CMOS unless you have a company, let's say Sony or Infineon, or there are a lot of companies that make sensor that actually make a sensor that is fast enough for your requirement. So if it's like sensor has to be like, okay, I can do 4K full HD, only then you can make a SoC behind it that can digest data at that speed. That becomes another issue. Let's assume you bought a sensor, like let's just say Sony semiconductor team is like, bro, I got you 10,000 frames per second, take it and go. And you're like, okay, sir, but our SoC can't digest that fast. So that becomes a second link. But right now, that's not that big of an issue. So modern SoC, basically modern mirrorless camera, modern mobile camera, modern even high-speed camera, generally have a CMOS that has A to D, analog to digital converter, directly embedded on the back end of it. And SoC is just taking the digital data and packaging it into video file. So that's why your SoC is responsible for downscaling. So it's capturing all of the data and then applying mathematical transform to downscale it. So all the downscaling, line skipping and all that generally happens on, it can be like you can talk to the A to D is like, hey bro, don't read those lines, skip those. And if it's a good SoC, it's like, no, give me the whole data and I'll mathematically compress it. So that's how it works. So let that be very clear. Right now, if you want to make a high-speed camera, the biggest issue is the sensor itself. So Phantom literally has to talk to the manufacturer, whoever their manufacturer is like, hey, I need a sensor that has A to D that is powerful enough to do this. Like they have to talk to them. It's like, and again, penalty of that would be it has to be bulk order. They can't silicon edge, oh, we're gonna make a one. Even though the sensor part is done, that is sorted, is the A to D, they have to custom develop it. It's expensive. So let that be clear. The sensor is the limiting block. And whenever you see this sort of footage where like actual projectile is moving at stupid speed and you can still capture it, it's simply because somebody figured out, put a high-speed camera, have a mirror that is going. It's much cheaper to rotate a mirror. And sometimes mirror is constantly rotating and then you are sync launching it. As in like you want a mirror to be already at momentum and generally running in a helium filled cavity. So it has very low rolling resistance and it's going super high speed, like 10,000 RPM. And then you sync it. That's how you get it. So let that be clear. Right now, the sensor's back end is the limiting element. Now, let's assume you solve the sensor. Let's just say some company gave like, I got you, fam. I'm going to give you the most amazing sensor. Or heck, I'm going to give you the sensor from, directly from Phantom series itself. Is the data that becomes an issue. Like same way film was an issue. It's like, yeah, we figured out a mechanism, but how big of your roller would be, right? Like you can't have a roller that's like, okay, I'm going to capture 8 minutes of rocket launch. Yeah, roll size would be like size of a building. So that was a limitation. Same limitation applies today. Data is huge. And again, in this scenario, you cannot do group of picture. You cannot like, okay, I'm going to keep this frame, keep this frame, delete between frames. It's like then high speed has no value. So it has to do what we call all eye recording, as in every frame has to be recorded. That's an issue. As in the amount of data is huge, as in because you are storing even at 1000 FPS, it's bonkersly high, like, ooh, kind of high, like it's heavy. And not to mention it's coming fast also. So even if you have like, okay, hard drive has the space, it can't read and write fast enough to deal with that. So not only the amount is huge, it is fast. So the only way we could deal with this in like, early 2000, the Mythbuster era was RAM sticks. Somebody figured out in Phantom. It's like, hey, we sorted all the sensor issue and we have SoC that can dump data that quickly. Where would you dump the data? RAM stick, computer RAM sticks. Buy bonkers amount of RAM sticks. Like if you open old Phantoms, they just have a lot of RAM sticks. That's where they dumped the data, because again, RAM is designed to handle that A, speed, B, read and write cycle does not wear down RAM. RAM is like, bro, that's what I was designed to do. I do not care. I can handle it. So you write everything in RAM, and then once you're done, like, okay, this is the shot, I want to save it, it goes into your SSDs. So, and RAM also allows one of the most amazing feature that nowadays is slowly trickling down to your consumer camera: pre-capture or pre-record. Idea is you half press a shutter and it starts to record. Now again, it will not do it if you have any mechanical component. It has to be all electronic shutter and all that. So you half press it, start, it's capturing the footage. Where is that going? It's going into your RAM, and it's continuous buffer RAM. As in like, okay, I'm gonna frame number 1, frame number 2, frame number 3, frame number 6. As now you go to 10, then it starts to delete number 1. Now you put in number 11, number 2, number 12. That's how keep doing it. So there is a continuous buffer. Basically, once you half press it, it does that. And let's just say you are capturing a bird, right? And you're like, okay, bird's gonna fly away. Birds are not very static and stable for a very long time. So you're like, okay, bird is there. You half pressed it. It's capturing. Bird flew away. Your brain will take time to photons to reach your eyes, your brain to process it, give the command to your muscle, and then press it. It will take time, few milliseconds. This puppy allows you to like, hey, don't worry about it. As long as you pressed it within the window, and window could be as long as 2 seconds, you're good. Like if when you like bat shot, like you are trying to that exact, no problem. As long as you can press the shutter button within the 2-second window, you're good. And that's how high-speed camera works. So if you see people who are doing high-speed footage, especially that slow-mo guys, there's always like, capture it. What they're doing, the camera is always capturing. It's just that when they say armed and triggered, if the camera is capturing, is going on. When they press the button, it stops doing that. It's like, stop, write the data to SSD. Basically, trigger simply means delete everything else. It's just like, we got it. We got the moment. That's why the trigger signal is there. And thankfully, SSD has gone through exponential growth in speed, like stupid speed. Although I do not like the idea of computers going like stupid high speed. It's like, bro, give me capacity. You still can't buy 8 terabyte SSDs, reasonable price. Like price is like painful. And I'm like, bro, give me only 600 Mbps, like, you know, full old school SSD. Just give me like 30 terabyte or something like that. Don't give me speed, give me data capacity. But again, SSDs have become very fast simply because they switch from SATA interface to NVMe interface, utilizing M.2 physical hardware and using NVMe protocol over PCI Express bus. How fast is that? Well, right now, if you buy a cheap one, it's still 1 gigabyte per second. Is like, bro, take it and go. How fast is that? Few years ago, that was the RAM speed. It is fast. At this point in time, you can do things. And be mindful, I'm talking the cheapest SSD you are. If you get a quality SSD, reaching 20 Gbps, small b, 20 Gbps is like, bro, who cares? 40 Gbps, meh. Who cares? And be mindful, the PCI Express was designed in such a way that it can keep scaling up. So even 8 Gbps is doable, capital B. And be mindful, servers already have that. It's just that normal consumer hardware has not reached there. So SSDs became fast enough where companies are now selling you a system captured directly into RAM. Now, RAM always had that limitation. It was fast, it was awesome, but it always had a limitation. As in like, I'm gonna record it like 20,000 frames per second. Cool, awesome, GG. How many seconds you can record? Yeah, 5 seconds. It's like, no, can't you record longer? No, RAM will fill up. So even though your SSDs could have space, RAM is like, bro, this is the limiting lock. Now you're directly writing it. So now you can have a scenario where it's like, hey, I want to capture whole SpaceX launch full from ground to as long as I can see in let's say 200 frames per second, take it and go. 1000 frames per second, take it and go. Because again, SSD can directly digest it. It does suffer with the penalty of like no pre-record, but you can work with that. And some company is trying to have a hybrid where they can give you pre-record using RAM and give you, because again, if you do that, like, you know, read and write on SSD will wear down. Not very quickly, but it will wear down. So it's like, again, there are companies who are claiming they can do it. And again, modern SSDs have very long lifespan, so it should be able to endure it. So that's how we solve the data part. Meaning, if you are buying a Phantom cameras that have like stupid high FPS, it is writing all the data into your RAM unit. Once you trigger it, it will dump the data from RAM unit to your basically actual slow SSD. And if you are still mid-speed camera, as in like 1000 FPS, it can directly write on SSD now. Like you do not have to worry. So what about the progress of the whole ecosystem? Well, consumer electronics have become a big deal. And again, I'm old enough where I remember when my father bought the first mobile phone of our family, that was Samsung C100, first color phone, like slim color phone. It was 1 centimeter thick, it was slim. And that time it was a big deal. It had 1000 names in a phone book. Yeah, I'm that old. I remember like people used to count, hey, I can store 250 names. Like, no, that's nothing. 1000. When was the last time any of you thought about like how many names you can store in your memory? So that's how we started, but right now we do not worry about it. So there's a lot of progress, but here's the progress happened equivalently in many things. Meaning in 1990, even if you were a genius, even if you were a rich genius, you could not do much. Like you really could not do much. You cannot just like, hey, let's just say I have a dream, I want to make a smartwatch, not smartwatch, like a digital watch that suits me. I could not have done that. But now we are living in the future, meaning I can literally buy modules, I can literally buy microcontroller, I can get custom built PCBs, and I can have even companies assembling it, meaning one person can do almost everything nowadays. And if you have money and time, go YOLO on it. So a lot of small teams are starting to crop in, and they're like, hey, let's break the stigma. Like, Phantom is cool and awesome, but here's the deal. If you're in a college and all that, yeah, you're not gonna get that. So what if you made something that is good enough that it works? So Kronos is the first time that this became mainstream. They started a Kickstarter in 2016, and let them be clear, all the data is available on YouTube. I would urge you to see it. This is what they launched at that time. And it might look crude, but from this was a very good example of like, know your customer. Like they knew, like they're not gonna able to compete because A, they could not buy a sensor that was high end enough, and again their SoC was not their SoC, it was FPGA unit. So they did their best, but again they made it so easy to use, so many convenience. Like that's why it has so many trigger ports and all that, because they knew if you are in engineering college, you need a external trigger system. If you are observing any sort of electrical phenomenon, you need external trigger. They sorted all of that. SSD, eSATA, that was that ago, long ago. eSATA was a thing. So like, directly dumping the data into hard drives and all that. So they did really good, and they became a company, a Canadian company, and they're still making cameras, and people are still happy with them. Like they're buying it and enjoying it. So, and a lot of colleges and all that, because either you can hope and pray that you are living next to a military corporation that is gonna like dump their ancient hardware, and then you're gonna, sir, please give us the ancient hardware, or buy this. So Kronos became a big puppy, and then Chinese companies started to get into it. Like for example, this company is Firefly Emblem, and again, they also had a Mark 1 product, which was not that great, not in terms of like the hardware abilities. The sensor was so old, as in like in terms of dynamic range. I'm pretty sure it's not the sensor, it's just the analog to digital converter behind the sensor was like, bro, I can't work at those speed. So this is Mark 2 variant, and this time the picture quality is good. And just a few days ago, Pixelboom also released their Kickstarter. And again, this has internal SSD, which I do not like. But again, they do solve one of the biggest issues, like how the heck you deal with the footage. No problem. They worked with Apple for some reason, or Apple allowed them to work with them. They give you raw ProRes directly in camera, meaning the footage, it's a ProRes raw. Like just plug it in, done. The end. Go home, done. I'm like, damn. Even Phantom does not have that. So it's like, damn. And then Pixelboom improved in one regard, downgraded in another. It has custom format, that's the downgrade. Benefit, it has external SSD, as in like SSD is a caddy, you can pull it out. And they made it so awesome that caddy itself has USB-C chips. As in, you pull out the caddy, plug the USB cable, directly dump at 20 Gbps. I have seen only one cinema camera company that is doing that. It's like, hey, you have M.2. M.2 is designed to work with like, there are USB chips that are like, bro, I can give you 10 Gbps, 20 Gbps, no problem. They're like, why not put that into the cartridge itself? So memory card itself is the card reader. You don't have to buy extra card reader. And they're starting with like, 2 terabyte. And I'm pretty sure they can easily go up to 4 or 8 terabyte. So that's a very unique way. And again, it allows you to, both of these are direct write. So they can work as long as their memory is empty, meaning minutes of high-speed footage. At 1000 FPS, minutes of recording, even Phantom will have hard time. This is like, bro, we got this, we good. And again, if you are like a music video and all that, having the ability to directly shoot in ProRes, shut up, take money. Having the ability to record a long session, like, full Falcon 9 launch, or super heavy launch, you can detect it. Like, bro, I got this. Camera is like, bro, I got this. Even Chronos does have the smaller sensor. Like out of all of these, Chronos have the smallest one, but again, lowest price. So amazing progress happened. Now here's the deal. What about the price? Like how big is? I will not tell you the exact number. I'll tell you the proportion of that number. Meaning, if you want this sort of feature set, how much money you are gonna pay? 1/4 of what Phantom is offering. Meaning, if you are willing to spend $100,000 on Phantom, you can get the same specs, same horsepower on these puppy for $25,000. Now be mindful, most of these are below $25,000. That is available for $8,000. 8 will become 12,000 once they are outside of Kickstarter. And again, they have shipped the unit to people and they're like, yeah, it is a real thing. This is ready for sale. This has been going on sale for few years at this point in time. So that's a very amazing jump. Like we went from only Mythbusters could have afforded it to like, hey, small YouTubers are owning it now. And I can easily see that in a cinema industry over time, it's like, yeah, just high speed is just a thing. You do not worry about it. Like 1/4 of the Phantom, that's like, damn. And be mindful, SSDs are like getting stupid fast. Like once you go into PCI 5.0, the speeds are fast. And sensors are also becoming better. So as long as you have the processor growing faster, sensor becoming fast, as in like the analog to digital converter getting faster, we good. We got this. We awesome. So progress has been amazing. So I can easily see in next 10 years price coming down drastically. And again, right now what is available, it was not available to Mythbusters when they started that. So this was my presentation on why the heck high-speed cameras are so expensive. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.